So to get started, then I will talk about what we're going to do today. I have a special guest, Jeffrey Cowen. He's did I say I don't know if Cowen? How do you say
You
that,
actually
Jeff?
said it correct. Nobody ever
Ah,
does, but you are correct. It is Cowan.
great. Well, there's one for today, anyways. So so Jeffrey is the one of the product managers for Autonomous Database Dedicated. So we have kind of a special guest for him to walk us through how you can set up a database of memory to work with your autonomous database dedicated environments. And we're going to go through, and I'll walk through that and then also talk about, show an example basically. And so that should be interesting, I think. And then my name is Andy Rivenis. I'm a product manager for database and memory. And as always, my email address, the blog URL, and these slides will be available on GitHub as I've been doing. And there's the link in the links that I showed you and the resources at the end of the AskTOM landing page. And what else am I supposed to say? Oh, and if you have questions, even if it's not about autonomous database, if we want to, certainly at the end we'll throw it open to anything. And if you want to type your question in the Q&A, we'll try to answer your questions. If you can't see something, please let me know. Just say, oh, you're not sharing properly, or the type's too small. We can make it bigger for you. So anything, and then of course any database and memory questions. So, and I'll probably pepper Jeffrey with a few questions or try to help explain what's going on. And of course, to be honest, I'll let him drive the autonomous database because he is the expert there. So with that, I think we'll go ahead and get started. Um, and so this is autonomous database dedicated. Autonomous database shared is coming. It's not yet available within memory, but it will be soon. We're focused on the dedicated portion, and it includes both ATP and ADW. I find this gets kind of confusing, but Jeffrey wanted me to make sure I included that information so that you can, in each of those two environments has different capabilities, but it is in memory is available in both of them. And we do have a blog post out with that at the top there. You can either, I guess, Googling, since you probably can't click on the link, but there is a blog post that describes also what we're going to talk about. So this is supported as of database 19.20. So it's 19C. We're not at 23C yet. So 19C, 19.20. It does require 4 or more OCPUs, and Jeffrey will talk a little bit about that as he's kind of setting things up, or 16 or more eCPUs. And I'm not even going to try to explain the difference there. And but that's kind of the requirements in order to have enough memory assigned so that you can enable database and memory. You can enable between 5 and 70%. We're going to show you all of this. So I'm just kind of just going through the basics, and then Jeffrey will walk us through how that all translates into setting this actually up. And then as you grow your CPU count, the memory count or the available memory will also grow. So the way autonomous database and I guess the cloud in general is set up is based on CPUs, OCPUs or eCPUs. The more you have, the more memory you get associated with it. And then that could be leveraged for database and memory for the IM column store. Now, the interesting note is we won't talk too much about this, but since we are talking database and memory on Exadata, you do have both IM column store and cell memory available, or database and memory columnar formats on Flash. So they both work together to allow you to have a very nice columnar footprints to allow you to do lots of analytics. Talked about in the past about reporting and analytic workloads. And then once you've got it enabled, we'll kind of go through a little bit of a session. We're going to use the simple demo that I created a while back as an example, but we're going to alter tables in memory. We're going to be able to show you how much memory is being used, what's populated. So it works, it's just in memory at that point because it's running on Oracle database. And so I think that's all I wanted to say with that. And then I already kind of mentioned there's actually a Live Labs for ADB dedicated that Jeffrey put together. And in this case, Lab 16 is kind of roughly what we're going to mirror in our demo. And so you could actually go back if you want and run the Autonomous Database Dedicated Live Lab, kind of try it out, see if this is something that might make sense in your environment. And then you could even try out the database and memory portion of it in Lab 16. So I have that link there as well. And I guess I should maybe start putting actually URLs you can copy and paste. But like I said, the labs are all available. The PDF will be available. So if you can't Google and find it, you can go to the my page on GitHub, look at the PDF for this information and get it there. Maybe I'll put another link on our resources page to make it easier as well. So anyways, to move on, we're going to go ahead and actually create an autonomous database dedicated instance, if you will, or database. We're going to create the column store or actually enable a column store and then run through a real simple demo, no pun intended, but our simple demo that I've created, it's basically just an orders tab table, one table. The kind of nice thing about the demo is it actually, if you choose to use it in maybe a different environment, is it'll create the data for you. It'll do everything all in one a SQL package, if you will, or a SQL script. And Jeffrey's already done the creating of the orders tab table because we didn't want to spend the time, the 3 minutes that it takes to create it in having everybody sit around waiting for that to happen. So we'll dive into that, and the table will already be there. So then we'll just populate it and show you a couple queries to prove that database and memory really does work on Autonomous Database Dedicated. So all of that, I think I got everything. Anything you want to chime in with, Jeffrey, or are we good?
No, I think you covered it good.
All right, so I have some examples here, but what we're going to do is I'm going to stop sharing and we're going to switch over to Jeffrey's screen and he's going to walk us through actually setting up the Autonomous Database Dedicated. So now you're on.
Before we begin, I actually just got sent this a few minutes ago. I'm not even sure if you've seen this, Andy, but this was just posted by some of our folks at EMEA. It's the Billion Row Challenge. Apparently, it's going around the internet here. All the excitement, and they used in-memory and autonomous dedicated.
Nice. I haven't seen that. Oh, that's cool.
Do it. So, anyways, well, we could send this out, on top of everything else you send out.
Yeah.
I just happened to get it, a few minutes ago while you were talking. I was like, oh, cool. So, yeah, they went through and used in-memory, and we could, another use case of it working. All right. So, inside the console here, I'm going to show you guys, how easy it is to kind of configure and get in-memory running in your autonomous database. So again, this is autonomous dedicated. So this is dedicated infrastructure, either in the public cloud or clouded customer. And I can see extra infrastructure, my VM cluster, my containers. But in this case, we're working inside the ADB itself. So here's a database. Actually, let me show you the other one first. Here's a database within memory, not configured at all. I can see database in memory is 0 gig.
I can I interrupt for a second? So you've already created an autonomous database, right? So yes, that's kind of a prerequisite that we're not going to really walk through that here. But you've already got this set up, and then you're going to describe how in-memory might get enabled once you've done that, right?
Exactly, yeah. So if you had an ATP or an ADW database already created, this would be the steps to turn on in-memory, as it's not on by default. We don't want to take the memory away from the SGA if you don't plan on using in-memory. So this database was freshly created a couple days ago. I have not done anything with it. So you can see the database in memory area is 0 gig. I can see how much memory I have per CPU. Now I can click the edit button here, or I can click manage resource allocation. They both take you to the same spot. Here we can see that in-memory is grayed out, and I can't click it because we've not met the minimum requirement of 4 OCPUs, right? So if I up this to 4 OCPUs, I can then turn on in-memory, and then I get this slider that says, how much of the SGA do you want to dedicate to the in-memory column store? And so you can use any, as little as 5% of the memory and as large as 70% of the memory. So from the SGA, I can take between 5 and 70% and just say that's for the column store and that is then reserved for in-memory usage.
And so 4 OCPUs gets you a total of 10 gigabytes of memory for the SGA.
I will. That's per OCPU. So let me go to my other
Oh,
database that already has, so we can show you as an example.
okay. We
Uh,
didn't, sorry guys, we didn't, this is a little ad hoc because we didn't completely, and for me,
so
I wanted to explain that how much memory 4 OCPUs gets you
yeah,
total.
so it's a little tricky because this is the default configuration, but in the OCPU configuration world, I can edit my memory to core ratio at the VM level. So you
Okay.
can, I can create a default with 10, 13 gig of memory, or I can up it to 50 gig per OCPU. And then so these ratios would be much different. But in our case here, this is kind of a default built cluster, and I've got the memory percentage set to 50%. So 4 OCPUs is giving me 11 gig of memory for the column store.
Okay.
So each one's a little, a little over 2.5 gig um, for each OCPU. No, yeah, a little more than that.
Okay. So, and then depending on what a customer might
Yeah,
have.
depending on what you've built, you
Okay.
may see a different ratio.
Right.
And then so the other thing, if I go in and decide I want to lower this over the weekend, to not get billed, right? If I'm up at 16 OCPUs and no one uses the system on the weekend, I can turn it down to 1 OCPU, and that's going to actually automatically turn off in memory. So we have to meet that 4 min requirement to leave in memory on. So this would end up, kind of flushing everything out of the column store, and then you'd
So
have to go
then
back
the
on
column
again.
store parameter gets set to 0 or 1 or whatever it
One,
is.
yeah, it's essentially set to one, yeah,
Yeah. And so it basically goes away. And
right.
then so when they come back and after the weekend, they'd
They would turn this
set it
back
back
on.
up and then
Yep.
repopulate all that. Okay. So I need to go through that
Exactly.
again.
So you have flexibility. We can scale online, turn off in memory online, turn it off, turn it on, turn it off. But there are times where you would be kicking things out of the column store. So, you know, but you can grow all these things. You can change this ratio. If I have more than if I'm wasting memory and I only need 25%, I can change this while things are online. So these are all dynamic and scalable online.
Right.
Make sense?
Yep. Makes sense to me. Hopefully, if
Yeah,
anybody has a
just a couple
question,
clicks.
let
Yeah,
us know.
you can do it through the APIs, et cetera, or just a couple clicks in here. No, we've done all the math and the configurations behind the scenes. So you're just setting a slider and seeing the value, deciding how much memory you need, and then working backwards from there.
So now is this the system we're going to connect to?
Yeah. So this is
Okay.
IM8V2.
So we'll expect to see a column store VDL in-memory area will be a total of roughly 11 gigabytes then.
That's right.
Okay.
Yeah, this database is currently, because it's only 4 OCPUs, it's only open on one of the nodes. So the other node is mounted and ready. But in this case, we're just going to be working on a column store that's on a single node. So I have kind of pre-built a script to walk us through this versus me trying to type everything in front of everybody. Assuming I
Always a
type,
good way to go.
assuming I type, I made this password very complex, and every time I was trying to test this, I kept getting the password wrong. But the cloud has high requirements for security.
It does. Yeah.
Okay. So, as Andy mentioned a bit ago, I already built the table itself. So, we're not going to sit here for a few minutes while we populate the table. But what we are going to show here is that in-memory works kind of exactly like it does on-prem, right? There's nothing different from that sense in the autonomous world, except that we've just configured it for you. But same kind of command, alter table, or orders tab, in-memory, priority high because we're impatient. And then we're going to go force in-memory to go populate the table into the in-memory column store itself.
Look, so let me interrupt you for a second.
Yeah, go ahead.
Let's so people don't get lost here. I'm gonna share a different screen just for a second. I'll let you come back.
Yeah,
Just
let me.
because I brought up, I was thinking ahead, and I did bring up so out on this simple demo that Jeffrey's showing you is actually available on GitHub. It's been there for a while, and so if you have a question or want to try to figure out what did we do to create the orders tab table, all this stuff, I actually have the output of it. So we just skipped over all this stuff, so that we didn't want to have to wait for that part. So I just wanted to just make it clear that you could do this. This is all like we do everything else on our Ask Tom Office Hours. The demos are all freely available for you. And so he's just already built this table so that we don't have to sit and wait for it. If you have concerns or want to try this for yourself, you certainly can do this, or you can use the live lab that Jeffrey's already built for you and do it that way. But I just wanted to point out that where this is, and again, this is I'll make sure I think it's already there, but the links are available either on the resources page or on the Ask Tom session. So all this stuff you can get to. So just that's all I wanted to say. So sorry, Jeffrey, for
That's
interrupting
a
you.
good point. I kind of jumped ahead, but in the live lab that I created, it references your GitHub, and that's where you get the files from. So
Okay, good.
thank you, Andy, for building all this. And so one thing I noticed
So
in
you
your
need to share your screen again. Sorry.
oh, yep. One thing I noticed in your screenshot is um, that your table is 4 times bigger than my table because in ADW, everything is HCC compressed by default.
Yeah,
First, I thought I
excellent.
did something wrong, but I was like, oh, wait a minute. So this table
Oh, so
in
that's interesting. So this
yeah, in
is
the
because
non,
it's by
X
default
data
HEC.
autonomous world, it
Oh,
was
yeah,
about
okay.
1.4 gig, and here it's 352. So, around a 4x compression. Anyways, just
Well,
it was
actually, and the funny thing is, if for folks that care about that, I mean, you can actually resize this in the script to make it bigger. There's a parameter in there to, if you want to get into that level of detail. So yeah, you can make it as big as you want. But for our purposes, the fact that it's HCC is interesting because then that gives you some columnar formatting already on disk and big space savings. So okay, so that's good to know.
yeah, if this would have been an ATP database, that would not have happened. So ADW databases specifically that you put objects in the data table space. The data table space has compression, HCC query high compression enabled by default. And
Which
so if you
which
make your
is
own table spaces, you don't have to do that, or you can turn it on. But in the ATP world, there's no compression by default.
which is interesting because notice that since it's only 400, 362 uh, gigabytes, I guess. Gigabytes or megabytes? That's
Megabytes.
gigabytes. Megabytes. So,
Yeah,
but
it's
notice
300.
our compression in the in-memory column store is about the same because at that level, HCC gives you compression on disk. So in my example, I didn't use compression, so it's like 1.4 gigabytes, and
Yeah.
then it compresses down to 400 megs. So anyways, kind of interesting to know how that all that stuff works under the covers.
Yeah, and it's all like I said, the HCC piece on disk is similar to, in memory column store. So
Yeah.
plus we can see that everything's been populated. And here we're going to run a query with in-memory enabled. So we can see the query ran very, very fast. And our here, maybe Andy, you want to give them a little color on what the query just did and what these numbers.
Yeah, so this is the second query because it's more analytical. The other one just kind of lists stuff out and just traipses through the whole thing. But this query is more of an analytical type query where we're looking for the minimum revenue for a particular order, or actually the order that has the least amount of revenue. And so it does a little more complicated query with a subquery in it. And notice that in the execution plan, we're generating Bloom filters to make the hash join run fast. And so we're taking advantage of all the in-memory, because this is just in memory at this point, in the column store on ADB. So it's just, since it's Oracle database, 19C, it just runs like you were running on premises for all intents and purposes. So, and then the other advantage in all of this is that cell memory is also available. So for, as I mentioned before, so for very large, environments where you have maybe you want the fastest data to be in memory. We've talked about this before, and then other data you can that's getting smart scanned will wind up in cell memory, reformatted into the cell memory format, and it all works seamlessly together because now you're not only are you getting autonomous database, you're getting autonomous database on Exadata, and you get to take advantage of all of those features as well. Yeah, so this just runs really screaming fast. Does all of our in tech table access in memory full we've talked about. Notice we got a Bloom filter created when we scan since we're doing two scans with a filter predicate, we actually build a bloom filter on the orders tab for that filter predicate, and then we apply it when we rescan it the second time. We've got the subquery in there. But anyways, that gets a little beyond what I cared about talking about today per se, but we've talked about in the past. So you can certainly go look at our other information on hash joins and even vector group bys for group by aggregation and such. And with that, I think you had a second one that runs no in memory.
Yeah, yeah. So it is interesting, the bloom filtering, the estimated rows and the actual, the amount of work that gets cut down by all the features in the database behind the
Wow,
scenes is pretty incredible.
it
And the
is.
other thing to note is we didn't have to do, if you're not familiar with in-memory, we didn't have to do anything special, right? We didn't point to a different table.
Correct.
This query wasn't rewritten. It was just the same query that was run against, I'll show you in a minute, the non-in-memory works within memory. So it's just a feature you enable and you automatically get a benefit. So
Right. So the big thing is you don't have to change your SQL to take advantage of it.
yeah,
Yeah, and then
so here's
you
just a
actually
couple of
included the
statistics.
statistics, which I don't know if I have on the other one, but yeah, so you can see the work there. So we're using a mem compressed for query low for the IMCUs. You can see that somewhere in there should be the total aggregated rows, which is down.
Here's the projector.
There you go, projected. And
Yeah.
so that's the other one of the we've talked about that in the past as well, the magic that occurs with being able to do the work during the scan of the data and just return the results as opposed to the row store where we've got to do a whole bunch of work throwing rows away, processing those rows, which is why that tends to be slower. Of course, since we're running on Exadata, I think we're going to find that it's not all that much slower for this very small subset, but it is different. And so the point is to show in memory that how in memory works. So go ahead and unless you have something else you want to talk
No,
about.
yeah, just the one thing to note is so this query ran in 0.02 seconds, and you can see it used in very little CPU, almost none here because in memory, helping us with the way the data is stored, we have to do very little work to get our answer out. So here is the non-in-memory version. You can see we've gone just to back. This is an Exadata, right? So we still have benefits of Smart Scan and all the other nice features. We have, we're now doing an access storage full instead of in-memory. You can see there's a bit more work on the actual rows we had to scan through. And it actually took about 10 times longer, which, zero point 0.02 versus 0.24, if you and I don't really detect a difference in that, but if I happen to have thousands of these running,
Right.
I'm using, let's say, 5 times less CPU, and I'm more
Well, and
efficient
realistically,
with
this is
hardware.
a tiny data set. Most people are
Right.
running, hundreds of gigabytes, if not terabytes of data that they're looking through. So then the
Yeah, as you
differences
extrapolate it
become
out
much more
farther, it's perfect.
pronounced, right?
Yeah.
So yeah. And then one of the interesting things about this, since you included the stats, is that we are on Exadata. So we're doing a smart scan. So at some point in the background right now, and I don't see, I did a blog post that talks about all of these cell memory statistics, but we're not currently seeing cell memory. But if we ran this a couple of times and waited, we actually probably would wind up seeing cell memory being used. And so that's kind of the other nice advantage of running autonomous database is that since you're on Exadata, you could take advantage of all the Exadata features and database of memory takes advantage of those features as well. But I don't see our cell memory statistics. So what we're getting though is still smart scans. So this compared to commodity hardware is, and I've shown examples of that, is much more pronounced. But again, data or Oracle database on Exadata can take advantage of cell memory or even just smart scans in this case, and that's parallelized under the covers at the storage layer, so it's still fast. So everything is fast, but within memory available, we get to take advantage of things. And I've been working with some folks on different types of hash joins, and we can use bloom filters, and so it makes all this stuff fast. And actually, if you go up, Jeffrey, if you go up to back to that execute right there, notice that because now in memory is enabled on Exadata, even though we're doing a smart scan, we're still taking advantage of our optimized hash join processing. So, to make this a fair fight, we would actually probably have to go in and figure out how to disable all of the in-memory features, which I guess you can't do in autonomous database, but I've shown you that in other versions. So you get both the best of both worlds basically here. And that's kind of the point of showing you that now this is available on dedicated. It will be available on shared. We're working on that right now. I don't have a date for that, but we are working on making it available because basically, not to get too marketing ish, but database memory is going to be available our goal is to make it available everywhere Oracle database is available. Certainly on premises, on cloud, on Exadata cloud service, all the places where you can run an Oracle database either on your own or through Oracle OCI, cloud interfaces. Database and memory will work and speed up all of your analytic processing. So, I don't know. I don't really have anything else to talk about. Do you, Jeffrey?
No, I mean, well, it's that easy. That's
Yeah.
the beauty of it, right? So
And
we
then
can
so
able to turn them on, and.
So if you were to, as you mentioned, you wanted, is that automatic or would you have to go back and turn off the CPU, say if you weren't doing anything over the weekend? When you do that, then this all just goes away, just like if you were to essentially recycle the instance, when the column store goes away, because this is all in memory in essence, right?
Yeah.
So does that cycling happen? I guess once you set a count, you can burst or whatever, but you'd have to actually set it to one or zero to save. If you have quiet periods, right?
Yeah, right, exactly. And we have customers that, for example, they turn this up when they have batch jobs that run like overnight. So they kind of go the opposite way. During the
Okay.
day, they might only need four OCPUs, but when all these ETL jobs kick off and backups are running and all these other things, they'll go in and crank this. Now, I don't have a lot in my VM, but they'll
Right.
crank this number up and then they'll get all these more resources and then they crank it back down during the day. But same idea that you can schedule any which way you need to go to grow, shrink, and all that happens on demand online.
So if they
The
were
only
doing
thing
batch
is if you go
reporting and
below
they,
four, right, you
yeah.
turn
So if they
off
were
your.
doing batch reporting and they cranked up their OCPU count, they might also want to crank up their in-memory percentage, right? So they wanted
Yeah.
to dedicate more memory to batch reporting because they're running, reporting or any kind of analytics and crank that up and then move it back down for say like you have two different workload periods, I guess, if you will, right?
Yeah.
Okay,
Yeah. Certainly could.
great. Guys, I don't have, there's no questions here for us to answer. This might be our shortest Ask Tom. I always say I want to run an Ask Tom in 20 to 30 minutes, and looks like we might achieve that. But if you do have a question, please feel free to sorry, I'm going to do two things at once to post any questions. And if it's about autonomous database, anything you've seen, or anything else about in-memory. So I did include what Jeffrey just showed us. And this is actually from the blog that we did as well. But the ability to the slider, the what it looks like before, what it looks like after, and then any other information you have. We have hands-on labs, and we also have an autonomous database hands-on labs, and I will make a PDF of this. But I'm still waiting for any questions. If no questions, then I guess we did a good job because it must be pretty straightforward. And we'll wait a minute or two more, and if not, then we're gonna probably sign off. And again, you can these URLs, and actually I do have the bit.ly for our Live Labs environment. And then there's actually two, but the bit.ly will get you to the first one, the initial one. And of course, then the URL for our resources page, which has all of these links in there, the Ask Tom link, the Live Labs links. I think I'll add, if you don't mind, I'll add the autonomous database, your Live Lab link is in there as well, added in underneath the other two. And then
Absolutely.
anything else that you might want to get. And now they're coming in. So let's take a look at some of the questions. But anyway, so if you get lost, that's kind of your focal point, in my opinion, of how to get to database and memory information. Does it cost to enable the in-memory feature? No, it comes as part of Autonomous Database. Great news there. You can use it. You don't have to pay for it. So yeah, so that's good news from that. That can we use in memory on other clouds, for example, in Azure. So the deal with that is that's a licensing question. What we wind up saying is you can use database and memory in other clouds where database runs, but there are limitations, and it has to be and I'm going to forget the term. It has to be an authorized cloud environment. And so I'm not going to try. It is possible, but I don't want to misstate since I don't think about this very often. But we do have people on, for example, Amazon cloud that run Oracle database, but there are restrictions. So I'm going to say it that way. And I would point you to the licensing documentation about in memory and the authorized cloud environment portion of that. And I'm not going to try to decipher it here. Will we get ADBS in the near future? So yes. So I tried to mention that. And so we're working currently on making this available, autonomous database shared as well. So currently it's available now today on dedicated, and it will be available it is in the near future. I just don't have a hard date yet. And we'll make that announcement when it's available for autonomous database shared. So that will happen. Yes, we're actually working on it as we speak, or some people are. I'm not, but some people are. So great. Thanks for asking those questions. And if we don't have anything else, I think we're going to go ahead and sign off. We'll give you just another minute if any questions come up. And remember, if you do have something you come up with later, feel free to email me. My email address is available on the sessions, and I'm more than happy to answer any questions that you might have. And I think you can actually even ask questions in the Ask Tom. There's a little section when you register that you can ask questions there as well. So our goal here is to get as much information to you as we can. And so with that, I guess we're done. That's pretty good. 35 minutes, got it through everything. Thank you very much for attending. And we'll sign off. And with that, do you have anything else to say in closing? Thank you, Jeffrey, for also, I should be remiss in not thanking you for helping me out with this. So with all of your keys to the kingdom to let us see how this really works on autonomous database.
Doesn't like hearing me cough for 35 minutes.
No, well, sickness
hopefully
is
it wasn't so bad.
Something we live with. No, so great. All right, everybody. Thank you very much, and we'll see you next time.
Take care, everybody.